Titan, by definition, an entity of immense power, strength, and energy, a suitable name for America's second-generation ICBM. It succeeded the less powerful and more vulnerable Atlas ICBM in 1962, but would soon be replaced by a more advanced weapon system because of the complexities of fueling and storing the Titan's liquid propellants. Consequently, a more practical ICBM, the solid-fueled three-stage Minuteman, was developed, and Titan was no longer the primary weapon system. Launched from a well-protected underground silo, Minuteman became the final answer to the problems of storing a fueled ICBM for long periods of time. The technology and reliability of the obsolete Titan ICBM was not lost to progress. The key to the success of the spectacular achievements of the two-man Gemini space flights, indeed the very heart of the program, was the modified two-stage Air Force Titan missile. It boosted a total of 20 Gemini astronauts into space in 10 milestone missions. Among the impressive accomplishments of the Titan Gemini program were the first American walk in space by astronaut Ed White, the first rendezvous of two orbiting Gemini spacecraft, and the docking of a Gemini spacecraft with an unmanned orbiting Agena spacecraft. Thus, the Titan II system survived the obsolescence of its original purpose and became a valuable launch vehicle for America's Man in Space program. Eventually, the Titan launch vehicle would serve the nation in an even greater capacity as part of the more versatile, powerful Titan 3C booster, which has become the standard space launch system for the United States Air Force. With an increasing awareness of the potential of space to military applications, the United States Air Force further enhanced the usefulness of the Titan missile by adding a third stage to the basic two-stage vehicle. Called a trans-stage, it can place multi-purpose satellites into precise orbits, performing with a stop-restart capability, much like a switch engine in space. Dubbed Titan 3A, it would become the core vehicle for the more powerful Titan 3C, which has two large, solid propellant strap-on boosters attached for added lift-off thrust. To accommodate the Titan 3C system, a new facility for preparing and launching the vehicle was constructed at Cape Kennedy, Florida. The Integrate Transfer Launch Facility, or ITL, can assemble, check out, and launch the Titan 3C with minimum delay and maximum efficiency. It is similar to an industrial assembly line whose end product is a Titan 3 space booster delivered to the launch pad, ready for flight. The launch preparation cycle for a typical mission begins when the Titan core vehicle is delivered to Cape Kennedy by an Air Force transport plane. The objective for this mission was to place dual advanced military communications satellites into stationary orbit, 23,000 miles above the Earth's equator at widely separated points. The C-5A cargo aircraft, the largest in the Air Force fleet, easily accommodates all three stages which make up the liquid-fueled core section of the Titan 3C. Even as the stages of the Titan 3C are being moved out, the giant C-5A aircraft departs. It would soon return with another vital cargo for the Titan 3C mission, the twin satellites which would be hurled aloft to serve the Department of Defense Global Communication System. All the stages of the Titan core vehicle are delivered to the 23-story vertical integration building, where they are assembled in one of 4 cells within the huge structure. Once inside, each stage is hoisted onto a mobile launcher transporter by an overhead bridge crane. This is a deliberate, careful operation which mates the 3 stages into a core vehicle 108 feet tall. The key to Titan's versatility in space is the trans stage. Its 16,000-pound thrust pressure-fed engines are designed to give multiple restart capability for changing orbits and to achieve lunar or deep space trajectories. In addition, it is from the trans stage that the intricate maneuvers of the mission are controlled by the launch vehicle's inertial guidance. Large vans equipped with railroad wheels which permit travel on tracks throughout the complex are attached to the mobile launcher. Electronic equipment in the vans helps conduct the complicated tests and simulated countdowns which prepare the Titan for flight. The vans remain connected to the missile during all phases of testing, from assembly of the core stages until the moment of launch, thus assuring integrity of the checkout and reducing the probability of any delays. After the assembly and checkout of the core vehicle is completed in the vertical integration building, parallel-controlled diesel locomotives transported over a double set of tracks to the solid motor assembly building, where 2 rocket boosters will be attached. Prior to the transport of the core vehicle to the solid motor assembly building, the twin boosters are constructed by stacking segments of the solid rocket motors into their flight configuration. The technique of stacking solid-fueled sections into a powerful rocket motor has provided the nation with a relatively inexpensive and flexible way to obtain large amounts of liftoff thrust. Each solid rocket motor stands 86 feet tall and weighs 250 tons. They produce 2.3 million pounds of thrust at liftoff. The 850,000 pounds of propellant in the solid rocket motors will expend itself in less than 2 minutes after ignition, and in that time will hurl the Titan core vehicle to an altitude of 20 miles. Attachment of the 2 solid-fueled rockets to the core vehicle completes the assembly of the launch vehicle. Now the Titan III is moved from the solid motor assembly building to Complex 40, where a complete systems check will be made before the payload is mated atop the powerful booster. Once again, the synchronized dual locomotives push the Titan and its launcher along the special rail system which leads to the launch pad. Designed as an integral part of the Titan III system, the Integrate Transfer Launch Facility is a unique method of preparing rockets for flight. It allows the simultaneous assembly of as many as 4 Titan III vehicles in either of 2 configurations. But perhaps most significantly, it permits complete checkout in facilities away from the launch pad proper, thereby occupying the pad only for the time required to install the payload, load propellants, and launch the vehicle. In the Titan 3C system, the emphasis is on flexibility, reliability, and economy. The launch vehicle delivered to the pad may be launched immediately or held indefinitely, depending on the mission requirements. The flexibility of the impressive Titan 3C is reflected in its payload capabilities. It can place 28,400 pounds into a low Earth orbit, 3,100 pounds into a stationary orbit 23,000 miles high, or send a 3,700-pound payload to the planet Mars or Venus. Once the launch vehicle is emplaced on the pad, a massive mobile service tower, 25 stories tall, is moved in to provide environmental protection and to give technicians access to the rocket and payload. Even as the checkout of the launch vehicle continues, the twin communication satellites, which would later be carried into space by the Titan booster, have arrived at Cape Kennedy. Carefully, the dual spacecraft are removed from the huge cargo plane. Next stop, the Satellite Assembly Building, located in the heart of the Cape Industrial Area. Here, the satellites will be subjected to extensive testing and interrogation. Thousands of questions must be asked of the electronic components which make up the vital functions of the spacecraft, and the responses must be correct before the satellite can be deemed flight ready. With the aid of the modern computer, which can process enormous amounts of data with incredible speed, the tedious and exacting task is accomplished in a relatively short time. The outer surfaces of the cylindrical spacecraft are covered with solar cells, which convert sunlight into electrical power, the lifeblood of the satellite. These, too, must be carefully inspected and tested. After all checks are completed, the satellites are transported to the launch pad, where they will be mated to the waiting Titan launch vehicle. This would be the last earthbound voyage for the communication satellites. The next journey, which begins when the Titan booster engines erupt into flame and fury, will take them 23,000 miles above the Earth. There, from widely separated stationary outposts in space over the equator, vast amounts of communications would be received and transmitted by the satellites to provide almost worldwide coverage for the Department of Defense. At the top of the service tower, a door swings open to clear a path for the payload. Slowly, carefully, the satellites are positioned above the launch vehicle and then lowered into place atop the Titan third stage. After a systems test is performed to verify the readiness of the spacecraft, a shroud or payload fairing is installed to protect the satellites from the atmosphere during the boost phase of the flight. Now the tempo of preparation quickens. In the Launch Control Center, located 2 miles from the launch pad in the Vertical Integration Building, the 6555th Aerospace Test Group and the responsible contractor personnel conduct a combined systems test. Hundreds of precise conformations are methodically made, just as they would be done on launch day. Propulsion, tracking and flight safety, pad safety, instrumentation. These and many more functions must pass the rigid qualifications for flight readiness. When results of the simulated countdown show that Titan is ready, the fueling operation begins. 350,000 pounds of self-igniting liquid propellants are pumped aboard the core vehicle, carefully monitored from a control station near the launch pad. Technicians who handle the toxic fuel lines wear self-contained atmospheric protective suits, which have a supply of liquid air for both breathing and cooling. Soon the task is done, and the military's most powerful booster, as well as the free world's most versatile launch vehicle, is poised for flight.
UTCs go.
STC, go. ALRC.
Go.
SO, go. SRO, go. Roger. Test group is go.
TC, flight safety.
Flight safety.
You verify override valve lockout indicators lighted?
Roger, your transmitters are not up yet, sir.
Roger. I'll meet the SRO on channel 1.
Roger, SRO, channel 1.
Once again, the skill, coordination, and expertise of the launch team is focused down to a precise moment in time, T0. But this time, the mighty Titan will roar to life and begin its mission of placing 2 communication satellites into orbit.
We have a go beacon. Roger, test group, TC.
You are counting, TC.
Modern electronics and man blend into an orchestration of activity controlled by the test conductor. Each heartbeat of the Titan and its payload is monitored and verified as the countdown continues closer to the moment of launch.
Space test group.
Test group is go, and you are cleared to launch.
Stand by for 10-second countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Telemetry data radioed to Earth from the launch vehicle indicates that the Titan 3C has performed its task well. Later, after a series of intricate maneuvers, tracking stations verify the success of the mission, and 2 more satellites serve the nation from their outposts in space. Titan 3C, a truly versatile launch vehicle, has given America a valuable operational capability in space. The power, flexibility, and economy of its launch system has significantly contributed to the achievement of many historic space missions, both military and civilian. Men, machines, space vehicles, and satellites, all of them vital links in a chain of successful missions. Indeed, each of them has performed with precision to make the legacy of Titan a very proud one for the United States Air Force, not only for what has been accomplished, but for what yet lies ahead in the continuing biography of a Titan.